Okay, so this one's probably not going to be as long as the other one. It's mostly definitions and then understand those definitions, but it's really important because about half of the stuff we do in the class is polynomials. So getting a firm understanding of polynomials, what they are, and the terminology is really important because they're going to be popping up a lot. So this is just kind of an intro to what they are. So I like to introduce some history behind all this stuff, which you can tell from the discussions we do. You do some research on the history of algebra. So finding the history of polynomials was a little hard, but I did manage to find that the first time that the word was actually used in English was 1674. And he said, those knit together by both signs are called by some multinomials or polynomials, that is many named. And this is, I looked up, I forget what the picture comes from, one of the online dictionaries. And so it basically had the same sort of origin, same time. And basically, so the word poly is Greek. So usually our math words are coming from Latin or Greek. So this one comes from Greek, which means many. And then the nominal part is actually Latin. So it's like they combine Greek and Latin. But that basically means terms. And in Latin, a similar word, nomen, means named. So it's like you've got many things, and that's where they get many named. Nomen means named, so that connects to what the mathematician Samuel Jakes said. So it's a mix of Greek and Latin to basically mean you have many things that are combined together. So that's where we get polynomial. So connecting that to the actual math definition of polynomial. So the way that math definitions are written, first time you're seeing one of these things, you're like, what does this mean? So we have let a naught, so that 0 that's sort of underneath a letter, that's the subscript, we pronounce that not, which is not N-O-T, that is actually pronounced N-A, or the actual word is N-A-U-G-H-T, which is an English word that is not used often anymore, but it means nothing essentially, or 0. So it's a naught, and then we've got a1 and so on until an. And these are real numbers, so just regular numbers. And n is a non-negative integer, basically a whole number. So a polynomial in X, meaning that our variable is X, is an expression. So expression means that we have no equal sign. And it has the following form. So we've got an, x to the n, plus a n minus 1, x to the n minus 1, and so on. And you get a2 x squared, a1 x plus a0 or a naught. And so an is not equal to 0. So essentially what we've got here is a series of things with variables. The exponents on the variables are increasing. You start with the highest variable or the highest exponent first, and then it counts down as you move to the right. And there are numbers in front of the variables or coefficients. And so the labeling there is just counting down so that there's a way of labeling them. You've got like if n is 10, that's the 10th coefficient, and then we've got 9 and so on. It's just a way of labeling the way that we have this math going on. And that an cannot be 0, because if that is 0, then basically that first term disappears. And so then we don't have that, so then it's a different polynomial. So each term, which is the thing separated by the pluses, is a term of the polynomial. So that's where they get the many terms and the many things added together. So if I go back to the definition here, knit together by both sides. So it just means you could have pluses or minuses in between these things. And so it's just a series of things with plus or minuses in between them. And they have a variable with an exponent, basically. But you could also have like x without an exponent, and you could also have just the plain number or a constant without a variable. So it's just things added together essentially is a polynomial. We do have some particular caveats about that, but first let's get into, I already said, let's see, I said that the a's were the coefficients. Okay, so the degree of a term. So we have this new word degree, and each term, which is the things separated by pluses and minuses. So, this is a term, this is a term. Every term has its own degree, and that is what the exponent is. So the exponent on your variable is essentially the degree for that term. And then because we write this from highest exponent to lowest, the highest one is called the leading term. So the number in front is the leading coefficient. And then the number without a variable is called the constant term. Because it's constant, it doesn't have a variable involved. So in regular words, I've sort of talked about this. We've got things with adding or subtracting in between the terms. So anything that basically is a series of things added or subtracted is a polynomial, except your variable is never in the denominator of a fraction, because then it's not in this form. It's never inside a radical, so it's never inside a square root or cubed root or anything like that. Your variables cannot be in those things. Your variables cannot be in absolute values. So basically, it's very specific. Your variable is just outside. It may have an exponent, and those exponents on the variable must be positive, and they must be whole numbers. So that's what makes something be considered a polynomial. So when we were solving linear equations, technically, if you have something that's linear, like ax plus b, or like 2x plus 5, that's a polynomial. So mostly everything we work with is a polynomial. We are going to be learning next week about things that are not polynomials, like radicals, and this week we did have some absolute value stuff, which is not a polynomial, but mostly the stuff we do is polynomials. So just to kind of put all the vocabulary together, and then some additional stuff. So standard form. We call it standard form when your exponents are written with the highest to the lowest decreasing. The degree of a term, I've talked about that. That's the exponent. So each term has its own exponent. The whole polynomial, the degree of the whole thing is the highest exponent. So you just look for what is the highest exponent. That's the degree of the polynomial. The term with the highest degree is called the leading term. The number in front of that is the leading coefficient. And then we do have special names for certain types of polynomials, the ones that we see most often. So if there is only one term, it is a monomial. So technically, if you just see the number 5, that is a monomial. It follows our definition of a polynomial, even though it doesn't have a variable. It is technically a polynomial, and it's a monomial. So the mon part, or the mono part, means 1. So like a monorail at Disney World actually just has one rail that it's on. Another thing, nobody wears monocles anymore, but that was just one eyeglass. So that word mono means 1. If we have 2 terms, then it's called a binomial, where bi means 2. So bicycles have 2 wheels. So that's where you get that. And then if there are 3 terms, it's a trinomial. So like a triplets, there's 3 of them. Tricycles have 3 wheels. And then we don't have names for anything with more than 3 terms. We just call those polynomials. So you're not really going to hear the word monomial a lot. You'll hear about binomials and trinomials, and knowing the difference between those. And then also you'll see the word quadratic, and there will be binomial quadratics and trinomial quadratics, and you're going to be getting into a lot of terminology here. So you're going to want to try to at least have all of your definitions in one place, to review it if you need to, so that you really understand what you're working with. Are any questions on vocabulary or anything so far before we actually do some examples?
I got it.
Okay. So first, we're just going to practice the definition of a polynomial, what makes it a polynomial, and why, just so you know how to recognize it. Because the way math is that we have a set of rules to follow, but you need to know what category your problem falls into so you know what rules to use. Because the rules for a radical is different than the rules for a polynomial. So you have to be able to recognize the difference. So first we have 4a squared plus 7b minus 3. So this is a polynomial. And this is a polynomial because we have terms that are added or subtracted. All of the variables have positive exponents. And basically there's no variables in any other place. So that is a polynomial. And this has 3 terms. This would be specifically called a trinomial because it has 3 terms, though the problem doesn't ask us to identify it, but it is technically a trinomial because there are 3 terms there: 4a squared, 7b, and then if you see a minus sign, we consider that a negative when we think of it in terms of terms. So that would be a -3 as a term. So the next one we have is 3/4 x squared y. So this is also a polynomial. So this is something that isn't part of the definition specifically, but polynomials can be made up of more than one variable. As long as it still follows the rule of a polynomial and we've got an x squared and a y connected together, it's still a polynomial. So this one is 1 term. So this would specifically be called a monomial because you have nothing added or subtracted. But we basically our variables have positive exponents. And we do have a fraction, but there's no variable in the fraction in the denominator. I'm going to just abbreviate. I should have given myself more room there. No variable in denom fraction, basically denominator of the fraction. So let's look at the third one, 6x plus 7 over x plus 5. So you can type in the chat or you can say it out loud. Is this a polynomial, yes or no?
No.
No. Why is it not?
Because there's a variable in the denominator. Sorry.
Oh, that's cool. You guys can both answer. I'm totally okay with that. Yeah, this is not a polynomial because we've got a variable in the denominator of a fraction. So if there's a variable in the denominator, this is something that's called a rational expression. So it has the word rational, and rational specifically means fractions. Okay, what about the next one? We have the square root, p squared plus 2p minus 5. Yes or no?
I think no, because it can't have the radicals.
That's correct.
Okay.
So because our variable is inside the square root symbol, it is not a polynomial. Now, if there was no square root symbol, this would be, but because of the square root symbol, it's not. So variable in the square root. Okay, 3x to the 5th minus 9x squared plus 2x, or 2 divided by x over 3. I almost read that out loud wrong. Yes or no?
No.
Correct. Now this is for the same reason as the one with the 7 over x. We have a variable in the denominator. So even though the rest of it looks okay, because we have that x cubed in the bottom, it's a no. What about the square root of 2ab to the 4th?
I'm say yes because I'm not sure about the square root, but I think it's only variables inside of the square root, and that's not a variable.
That's correct. This was a really tricky one, and I expected that you guys to get it wrong. This is a polynomial for that exact reason. The variables are outside of the square root, so it's okay. So you can have polynomials with square roots with numbers, just not variables. So the variables are outside the square root. And this is a really important thing, is that the square root, wherever that top line is for the square root, it's only on top of things that are in it. So you have to really pay attention to how long the line is going, because if the line goes, if the line was above the A, then the A would be inside of there. And when you're writing these things by hand, you have to make sure that your lines are covering exactly what they're supposed to cover. Because if you don't cover the right stuff, then what you've written is incorrect. The length of the line matters. It has to only cover what's inside of it or what's under it. Okay, next one is 3 times the absolute value of y plus 2. It's okay to guess.
That one's a no, I think, because it has the absolute value in it, right?
That's correct. Yeah. The absolute value, it has specifically the variable is in the absolute value. If it was a number in the absolute value, it would be okay. So it's all about the placement of the variable. And then the last one, we've got negative 7x cubed minus 4x squared plus 2x minus 5. And anyone who hasn't spoken up, you can type in the chat your answers if you don't feel comfortable speaking. You can even chat just me if you want. Okay, we've got an answer. Yes, that is correct. So that is a polynomial. We have all these variables with positive exponents. They're not in any of the other situations. And that's a very traditional type of polynomial you'll see, with multiple terms like that, numbers in front. You're counting down your exponents, 3, 2, the 2x is an exponent of 1, the 5 is basically an exponent of 0. That's a very traditional polynomial. They usually just have one variable. We don't normally work with polynomials of multiple variables in this type of level of math. Are there any questions? Okay. So I've got a couple examples that are going to be like this. So I've given us a polynomial. So first, we want to write the polynomial in descending order, and this is what we call standard form. So standard form is where you have the highest exponents first, and then you count down your exponents to put them in order from highest to lowest. And you need to make sure you pay attention to where the minus signs are because they travel with the term they're in front of. So we've got 10 minus 8a minus 8a cubed plus 2a squared plus a to the fifth. And so we've got our a to the fifth first. And Andrew is like on the ball here, already giving us. So we don't have an a to the fourth, which is totally fine. Our next one is minus a cubed. So you have that minus that's going with the a cubed part. And if you're doing this, on paper, sometimes it's just best to kind of cross it out so you remember and make sure you don't miss anything. Next, we have 2a squared. And then we have minus 8a and then a plus 10. So I like to cross them out just to make sure that I haven't forgotten a term, because that's very easy to do, is to start trying to rearrange it and then you've forgotten something. And then all of a sudden everything's going to be wrong after that. We don't want that. So that's standard form from highest to lowest, and you may not have every exponent in there, and that's okay. So 2, identify the leading coefficient. So that is based off of, you have to have it in standard form first. And then that's going to be the first part here, and it's the coefficient of that highest term. So we don't have a number in front of there, so the coefficient is 1. So that is basically a 1 in front of there, which means our leading coefficient is 1. So if there was an actual number, you would put the number there. If there's no number, it's going to be 1. And then part 3 says to identify the degree of the polynomial, and then that is going to be the highest exponent that you see. So that's pretty easy. The highest exponent we have is 5. And so that's on the leading term. And so that's the degree of the polynomial. So this is a 5th degree polynomial. We don't have any special names for this. I guess sometimes for degree 5, you might see the word quintic, but that's very rarely used. So I would not even bother writing that down. Any questions? Okay. Same thing, but I'm throwing in different variables. And this is where it gets kind of tricky for people. So when you've got lots of variables, how do you determine which goes first? It says write the polynomial in descending order, but we've got many variables and they all have exponents on them. And it's like, well, do you pick the middle term because it has an exponent of 8 there? Or, why is it Q? Is because P is alphabetical order. Do we want the highest exponent of P first? How do you know what is the descending order? So when you have lots of variables, and in order to really decide it in descending order, we look at the degree of each term to order it. And so to get the degree of each term, it's the highest exponent of each term. But when you've got multiple exponents, what do? You add the exponents to get the degree. So we have to get the degree of each term. So if there's a variable without an exponent, you put 1, and then you add your exponents together. So this term, 2 plus 1 plus 5, is 8. So this term is a degree 8. So you're adding your exponents on the P, the Q, and the R. And then we do the same thing in the next one. So that P doesn't have an exponent, so we can treat it as 1. So we got 1 plus 8 plus 2, and that's 11. So this term is considered a degree 11. And then the last one, that R doesn't have an exponent. So we have 3 plus 3 plus 1, which is 7. So that's going to be degree 7. So once you've decided the degree for each particular term, once you add all those up, then you go from highest to lowest, which is going to make our middle term first, because that's degree 11. And then we'll have the degree 8 and then the degree 7. So descending order. And I'm not going to call this a standard form because there's not really a standard form when you have multiple variables, and different textbooks will give you different rules. Some will say do it in order, highest to lowest for the first variable, in the alphabet, which would be to order it by P. Each book or person kind of has their own rule for this. There's not really, this is one place in math where there isn't agreement. But I go by the total degree so that I don't have to decide variables, letters, all that kind of stuff. And that works really great if you're in crazy worlds where you have Greek letters for your variables, because that does exist. Because if you get into really high level math and you've got Greek letters for variables, well, good luck trying to figure out alphabetically which order they come in. So I go by the total degree, which would put our middle term first. So that would be 4 P Q to the 8th R squared. And then the degree 8, so that'd be minus 8 P squared Q R to the 5th. And then the last one plus 5 P cubed Q cubed R. So now that we've got our order, we can identify the leading coefficient, and that is going to be 4, because that's the number in front of our first term. So the leading coefficient is equal to 4. And then the degree of the polynomial is your highest degree of the term. So whenever you're asked to find the degree of a polynomial, you need to find the highest degree anyway. You have to get the degree of each term anyway, which is another reason why I do it in this order, because I have to do that anyway, get the count, add those things. So our highest is 11. So this means the degree of the polynomial is 11. And there's certainly no name for an 11th degree polynomial. Now, you're not going to encounter these types of polynomials too often, beyond probably this week. You'll see things like this when you're factoring polynomials, or you're going to be multiplying polynomials together and you'll create things like this. But as we get later in the course, we're going to stick with one variable polynomials. And so you're not going to have to deal with this kind of stuff too often. It'll be more like the previous slide. Any questions? Okay, so I've got one more example here, and then we've pretty much gone through all of the stuff about polynomials and gone into the little details that they don't really tell you in the book, or, like the book wouldn't really go into detail something like this, but it's important to know. So we're going to categorize each expression, and what I mean is determine, so these are all polynomials, and we want to determine, are they monomials, binomials, trinomials, or we'll just call them polynomials if they're not one of the special ones. And then we're also going to practice the degree part, because what's important to note is that the degree is not related to the name of the polynomial. And so I want to make sure that we get that clear, that if it's a binomial, it does not always mean degree 2. So degree, this first one, we've got 10x squared plus 5x. So you've now seen 2 examples of finding the degree of a polynomial. And this is a 1 variable one, so it's pretty simple. So what is the degree for our first example that we have here?
2.
2. That's correct. Yeah, so 10 is the leading coefficient. The degree is 2 because that's the highest exponent. Now this has 2 terms. So this is a binomial, because there are 2 things separated by a single plus sign. Okay, next one, we have 7z plus 13z squared minus 15. So I see we've got a 2 for the degree, because that also has a highest exponent of 2. This one has 3 terms. So we've got a plus and a minus symbol. So there's 2 separations, which means we have 3 things. So this is a trinomial. So third one we have is 6x squared. So this one also is degree 2, but this is 1 term. So this one is a monomial. So just from the first 3 here, they all have an exponent of 2 as the highest exponent, but they're different. We've got binomial, trinomial, monomial. So the degree, if the degree is 2, we often call that a quadratic, as that's the special name for degree 2, but that doesn't necessarily mean that it's a binomial or a trinomial. It can fit in all 3 of those categories. And quadratics come up a lot. We do a lot of studying these special types of polynomials. So, and that's a quadratic, which has an exponent of 2. And I think I have a video on that. Quad makes you think 4, but something that has 4, like if you think of a square, 4 sides, it's square, and that's why it gets the name quad, because these are squared things for the degree.
A little contrived, but all.
That's the history. I did some research into the history. That's why they named it a quadratic. I would not have chosen that, but
No, I'm saying it was contrived from their end. I'm not saying you invented
yes,
it.
yeah. Well, I mean, some of the words that they come up with, if you have to go on to pre-calc, they learn about the history of things like hyperbolas and parabolas. The word for parabola really makes absolutely no sense. I think that one is really contrived. Okay, so the next one here is 9. So this is a tricky one, and I see that
I had 2 possible things.
yeah, Andrew already had a guess.
It's probably one of those 2, maybe.
Yeah, is this a degree 1 or a degree 0? Anyone else want to give a guess at which one they think it is? It's one of those. It's either degree 1 or 0. Well,
I say 0 because we've only been counting the exponents on the variables.
We've got a guess of 1. We've got a guess of 0. That's a very good thought of 0, and you are correct. There is no variable, so it is degree 0. Now, technically, this is 9x to the 0 power. Anything to the 0 power is equal to 1, which is why we don't write it, because it would just be 9 times 1. But technically, it is to the 0 power. Like if we go back and we were decreasing our exponents here on the a, It would be an exponent of 1, and then this would be an exponent of 0 if you're following the pattern. So constants, just numbers, are degree 0. And this is considered a monomial because we have one term. And I accidentally switched my colors. Oh well. So that one specifically I put in there to see where you guys went and what your thinking was, because I can see how people would think 1 and I can see 0. And so I wanted to see where you were all at. Okay, 2y minus y to the 4th. That is degree 4. I want you guys to tell me what is the special name for this one. So give me the other side.
Binomial?
Say that again?
Is it a binomial?
It is a binomial, yes. So there are 2 terms. Okay, how about the next one? You guys can give me both. And Andrew, you should just wait and let other people answer.
Sorry, I'm so sorry.
It's okay. I want to give everybody else a chance.
Yeah.
So Dylan says 1, and it is a binomial. So yes, degree is 1 because we have 1x there. If you don't see that exponent, you assume that it is 1 up there. And then this is a binomial because we have 2 terms. All right, next one, 2y to the 4th minus 3y plus 1. I'm happy to take an answer from anybody. Dylan's going to go again. Degree 4, and this is a trinomial. All right, next one. Let's see how much you remember from my previous slide. Negative 32 x, y, z. What is the degree? And then the name. Don't worry, I'm not going to call in anybody. But I welcome everybody to give a guess. We've got a degree 3. So there is a 1 on the x, a 1 on the y, a 1 on the z, which adds up to 3. And then this is a monomial because we have 1 term. Okay, last one. Andrew, if you want to give this one, you can. You were quiet for a while.
It's 4 and it's a binomial.
That is correct. So the highest exponent here is 4, and it's got 2 terms. So this is a binomial. So hopefully you can see that there is basically 0 correlation between the degree and the name of it. And that's really important because a lot of people get confused there. So these are not related. They are measuring 2 different things. And so you could have multiple names. You could have a quadratic that is also a trinomial. They're talking about different properties of it. Like the term quadratic is specifically talking to the degree, while trinomial is talking about how many terms you have. So they're talking about different things. So important to understand, especially when we get into factoring, because there are rules for factoring binomials and rules for factoring trinomials, and they're factored differently. And so you need to understand the difference so that you know what methods to use. So just wanted to make sure that everybody had a good understanding of the vocabulary here, because half the battle of algebra is the vocabulary. One thing that is far underrated that people don't realize is that, like, at the top of every problem, when it says simplify the expression, whatever it's saying there, it's giving you clues on what you're supposed to do. So you really have to know those words and understand what they mean. And you have to be able to recognize what type of problem you have so you know where in your notes you need to look for what to do. So, are there any questions on this slide? Okay, are there any questions on it? We've got, if this is all I had planned for this particular topic, but if you guys have questions on other things, I do have 20 minutes that I can hang out here and do other things and answer other questions if you guys want. Or if you're mathed out, you're welcome to leave. I know some people, usually on Sundays, people get mathed out pretty quickly because you spend all day doing math. So, but I am available if you guys want some additional help.